So what are we noticing about these logarithm graphs in general? Well, if we think about what they look like is whether they're increasing or they're decreasing, is we notice they always start out with a vertical asymptote at 0, and then they go off to the right. That means that you can only plug in values that are greater than 0 into a log. So what this turns into is that you need to make sure that whatever's inside of a logarithm is greater than 0. So when we're asked to find the domain of a logarithm, that's what we're going to look for, making sure whatever's inside the log is greater than 0. I know we did something similar with square roots or even roots. We said whatever was inside needed to be greater than or equal to 0. Notice we're not doing greater than or equal to. We're just doing greater than. We cannot include 0. Why? Because it's an asymptote. So we're just going to use regular greater than, not greater than or equal to. So let's take a look at a couple of these. So starting out with some examples with finding the domain of a logarithm by hand. Well, what that means is whenever you have a logarithm, whatever's inside the logarithm needs to be just strictly greater than 0. So for problem A, what's inside of that log is the 1/2 x. So that is what we're going to be worried about, is that inside part, that 1/2 x, needs to be greater than 0. Well, how would you solve this? Well, you'd solve it just like you would an equation. Get rid of the fraction by multiplying both sides by 2. That will get rid of the 2 and will leave me with just a 1x, which is just x, is greater than. Well, on the other side, notice what you have. You have 0 times 2, which is, well, 0 times 2 is just 0. Okay. So we have our domain, but it's not in a format that we like. We always want our domain in interval notation. That means infinities, parentheses, brackets, that sort of thing. So we need to take this domain of x greater than 0 and convert it. Well, greater than 0 means we're going to be pointing to the right. The fact that it's greater than, not greater than or equal to, will mean that there's a parentheses here at 0, not a bracket. So if we write this out in interval notation, it will look like the graph above, where we start our graph with a 0 and a parentheses, and we continue on to an infinity. Remember, infinities always have parentheses, and that's our official domain, 0 to infinity. Be careful, just because we always have a greater than symbol doesn't mean it's always going to stay as pointing towards infinity. It won't necessarily. Remember, there are different things that will cause the inequality to switch directions. One of those things would be multiplying or dividing by a negative number on both sides of an inequality will switch the direction of the inequality. So it won't always point towards infinity. Beware. Let's take a look at B. Again, on B, we're going to do the same thing. We want the inside to be greater than 0. Well, the inside is a little bit different this time. The inside this time is an x squared. We're still going to set it up the same way. That x squared needs to be greater than 0. Now, we did something like this a long time ago, back, I believe, in chapter 4, is when we said that you've got an x squared term and you've got an inequality, you have to draw the graph. Well, x squared means that we've got a parabola graph. So we're asking for when is that thing greater than 0. Well, let's draw the parabola for x squared. Well, the regular x squared graph goes through the origin, and it hasn't been shifted, so it will look something like this. So when is it greater than 0? Meaning when is it greater than 0? When is it above the x-axis is everywhere almost except for only one value where it's not greater than 0, and that's here at 0 when you're actually equal to 0. So when is it greater than 0? Everywhere but that yellow point when we actually equal 0. So how do you write something out like that? Is everywhere but 0? Well, we've done that before. Well, that means everything to the left of 0 and everything to the right of 0, just not 0. And we write that as a union. So we'll write that out as the domain as negative infinity to 0, union 0 to infinity. Notice the parentheses here on both sides make sure that you're not including 0. And the reason why you can't include 0 is because we want to be greater than 0, not equal to. And at 0, we are equal to 0. So we have to leave out that value. Let's try another one. Let's look at C. On C, it's the same idea. If we're finding the domain of a logarithm, we need the inside of the log to be greater than 0. Well, the inside of this log is x squared plus 16. So we'll take that negative x squared plus 16 and set it greater than 0. Again, if you've got an inequality that's got an x squared in it, you need to draw the parabola graph. What do we know about this parabola is, well, we know actually a couple things. It's been, because of the plus 16, it's been shifted up 16. So it's way up here at 16 is where the vertex is. And also, because of the negative out in front, we also know it's a parabola that points upside down. We also know where it's going to cross the x-axis because that's when it equals 0. We talked about this before. When will negative x squared plus 16 equal 0 when you cross the x-axis? Well, you can solve this like you would a normal equation. Subtract the 16 from both sides. Now don't worry about the negatives because we can just divide both sides by a negative 1, which will give me that x squared equals 16. But remember, to solve this, I need to take the square root of both sides. Don't forget your plus or minus symbol, which gives us that x equals plus or minus 4 is when we're going to cross the x-axis here at negative 4 and positive 4. That's those two values. Now, why is that even important? Because remember, I'm worried about when is this parabola greater than 0, meaning above the x-axis. Well, where is it above the x-axis? It's this part of the graph that's on top. Well, that part of the graph starts here at negative 4 and goes all the way to positive 4. The question is, do I use brackets or parentheses? Well, I said I wanted to be greater than, not greater than or equal to 0, so we're going to use parentheses. So my domain is everything between negative 4 to 4. We're not including negative 4 or 4. That's what those parentheses are saying because that's where I equal 0. And I want to be greater than 0, not equal to. Last problem, problem D. This one's a little bit simpler, but we still have a logarithm. To find its domain, we're worried about the inside being greater than 0. Well, the inside of this last log here is a negative x. So if we're worried about that being greater than 0, well, we still have to solve this. We still have to get the x by itself, so we'll have to divide both sides by a negative 1. Be careful though, this is a huge step. We divided both sides by a negative. What does that do? That switches the direction of the inequality. So this is now going to become now x is less than. Well, the other side will stay the same though, because on the other side, we have 0 divided by a number, and we know that 0 divided by anything is still 0. So we've got x is less than 0, which means now our graph is pointing to the left at 0. It's still less than, not equal to. So we'll use a parentheses, which means our domain is what if we were to read this graph? It starts with an arrow, so it'll start at negative infinity and go up until 0. We can't include 0, so we'll use a parentheses. That's our domain for this last log. So the only time we really have to worry about drawing a picture is when we have the x squareds in it, because then we have to deal with drawing the parabola to figure out what's above and what's below the x-axis, to figure out what's greater than 0. Let's look at problem